Hey, everybody. Thank you so much for joining us today. We have a really exciting session, but I'll kind of give everybody about 10 to 20 seconds just to join the call and get settled for a second. So if you just joined, feel free to, take a sec. Also, thank you so much to those of you who joined us last month. We had a really great webinar kind of going over the basics of eBPF and how eBPF and Linux security kind of tie into one another. So definitely recommend if you're curious about eBPF, go and check out that webinar or just check out eBPF resources in general. But yeah, for this month in March, we have a really exciting session and a lot to cover, covering container and K8 security solutions. So we're going to focus on the CI/CD pipeline today. But before we get into all the fun stuff, why don't we give a quick introduction? Saurabh, you want to introduce yourself?
Yeah, hi everyone. My name is Saurabh Wadhwa. I'm a senior sales engineer at Uptycs. And prior to Uptycs, I worked in a UEBA SIM space as well as threat intel. And today I would be taking you through the platform and showing you how Uptycs can help you with the containers and K8s security.
Perfect. Yeah, thank you so much. You have a really interesting background, so I'm excited for you to get to walk us through it all. For those of you who don't know me, I'm Jeremy. I'm a technical product marketer here at Uptycs. Prior to Uptycs, I worked at Deloitte focusing on day-to-day security operations and systems engineering for government clients. And yeah, in my spare time, I enjoy playing and watching soccer. So now let's take a look at the agenda we have for today. So a few housekeeping items. This session is expected to go around 30 minutes. So first on the agenda, we'll actually move on to the key insights. So we wanted to give you those key insights early on so you can keep seeing them appear throughout the rest of the demo and discussion. Then we'll move on to our discussion of industry challenges around containers and Kubernetes security, as well as discussing recent adoption trends as well. Then we'll move ahead, dig a little deeper and focus on specific container security challenges at each of the build, deployment, and runtime solution stages. Then I'll hand it over to Saurabh, who will kind of give us a demo walkthrough, going through the single pane of glass, walking through each stage of the CI/CD pipeline in the Uptycs tool, before we open it up to the open Q&A. Of course, we have the open Q&A at the end, but feel free to ask questions along the way and we'll keep an eye on the questions box. So for the key insights here, we want to share these insights with you so you can see them throughout the rest of the presentation. And for the first point, it's relatively simple, but expanding attack surfaces have left an infrastructure sprawl for security teams to manage. And within that sprawl of hosts and assets, the speed and scalability of containers just requires a unique focus for these overstretched security teams. So teams need to be really purposeful with getting visibility into their container assets and account activity going around their CI/CD pipeline. For the next point, adoption trend shows that we are interestingly still quite early in the adoption and usage of containers in Kubernetes. So this leads to an immediate security gap for DevOps observability as teams scale up their container pipeline usage and work through the process pain points of ensuring a secure container build, deploy, and runtime operation. And then finally, teams have been shifting left, but teams need to make sure they're shifting left in the right ways. And that traditional CI/CD security approach is to target code builds, check images for vulnerabilities. And while this is great, we also need to think bigger and shift even further left than just traditional CI/CD approaches. For example, scanning code is great, but what if the laptop your developer is working off is already compromised by a malicious Chrome extension? And that has actually happened before. A developer thought they were downloading a Postman extension for Chrome. Turns out it was a clone of the real extension and was actually spyware. And this is just one quick example of how we want to expand and break the mold for how we think about shifting left and kind of the assets around your CI/CD pipeline. So moving on from the key overviews, let's take an industry look at adoption rates. On this slide, I want to take a look at the adoption rates for Kubernetes and containers. And here we can see that in the last 12 months, 31% of developers have used Kubernetes and 57% have used containers. And what this tells me is that it's actually still really early days for Kubernetes and containers. Honestly, this was a pretty surprising takeaway for me. I feel like containers have been exploding in adoption in the past decade, but we're still so early in the long-term usage of this technology. So obviously teams are increasing their usage of containers in Kubernetes, but attackers are also taking notice of this rising Kubernetes and container adoption. So let's break down some of the notable threats kind of into three main talking points here. We're going to cover scalability, public image repos, and a focus on Linux and containers. So the scalability of containers is really useful from an ops or DevOps perspective. For attackers, though, they create this ripe opportunity for just a whale of a target. Attackers can find one small flaw and use it at massive scale for crypto miners, taking over devices for a DDoS attack, or just a plethora of other issues or use cases as well. So attackers are also planting container images with malware in public repos. So this creates a problems in the DevOps supply chain, and teams need to be really vigilant about the Git or image repos they plug into their DevOps pipeline. Finally, a side note here is that Linux systems in particular are being targeted on the rise, with actors noticing a lack of security support and tools tailored specifically for Linux systems. So Linux tends to be the primary OS teams use for containers. So concerns around Linux really amplify when we look at the container space. And coupled with the growing adoption rates of containers, this kind of becomes a systemic issue at scale. So security is shifting left and becoming integral to how teams architect their products. Monitoring the CI/CD pipeline is the ideal place to start when addressing container security. But we want to make sure that teams are shifting left in that right way when we're talking about that observability around your pipeline. So let's look at a few of the challenges that teams face. Starting with the build stage, we'll then move through deploy and then runtime. So at the build stage, team struggles tend to revolve around ensuring you have a stable and secure build. What this actually means, though, is you need to validate any repos you have plugged in and make sure that these builds are constantly being scanned and assessed for potential vulnerabilities or misconfigurations. Moving into that deploy stage, things change between the time of a stable build and the time you actually deploy. Scan images during the deploy stage because this is your last chance to ensure compliance before your asset hits production. And let's also look at just using Log4Shell as an example. Imagine you had a container build using Log4j in, say, November of last year. You brought that asset down because it's maybe only needed ad hoc on a monthly basis, and it's spun up in October at the end of the month, November at the end of the month, and suddenly it's December and you're going to spin up this asset with Log4j. So suddenly it's December and you're ready to deploy again. You want to make sure that you catch these changes needed for that Log4j asset because it may be shifting through your pipeline in untraditional ways where it doesn't go through the build process again. It just kind of sits in that deploy stage waiting to be deployed. So at that deploy stage, make sure you're staying vigilant on your assets. For runtime, monitoring your runtime assets is the highest priority, and having poor data or maybe only periodic scans will lead to only a partial view of your production runtime. So at this stage, teams are being tasked with doing it all. Teams struggle with getting clear visibility and the high fidelity data needed for detections. In general, though, traditional CI/CD monitoring misses the visibility needed even further left of the build stage. So as looking into those developer laptops for compromised machines or malicious Chrome extensions we talked about earlier, we want to think of our CI/CD pipeline as not just this linear pipeline that assets move through, but as an ecosystem in and of itself that requires observability and insights across the board for the assets and resources involved. So now let's take a look at some of the solutions at each of these stages, keeping in mind, we want to fix the problems as early as possible because it reduces the amount of security gaps that we'll see later on. So when we look at the build stage, let's just pause for a moment and look at this graphic emphasizing the importance of catching and implementing fixes at that build stage. So for the benefits of shifting left, shifting as far left as possible gives you more control over your ability to remediate. It costs less resources to fix a misconfiguration, and there's also less bureaucracy, which allows you to fix it faster and at scale. Talking about the snowball effect, shifting left reduces the cost of fixing findings and prevents a snowball effect of that one single CVE turning into hundreds of deployments and then thousands of alerts. And kind of rethinking that final stage of thousands of alerts, I also like to think of it as thousands of potential gaps in your system. So moving on from that build stage of we're reducing vulnerabilities over time, we're kind of taking away that snowball effect. At the deploy time, it's a really interesting step in the CI/CD pipeline. A lot of people tend to focus on the build time or the runtime. And you hope that you've addressed everything in the build stage, but we know there's a balance between speed and security for your deployments. So these threats evolve. As you move from the build stage, threats evolve and prior configurations may need to change. Take Log4Shell again. teams had to stay vigilant and constantly adjust deployment configurations as new permutations were published. By that third week of December, the changes and updates you made in that first and second week of December, most likely not viable. In fact, they weren't viable. Also at the deploy stage, this is your last chance to change things before production. You want to fix a configuration and ensure compliance to ensure trust. So anything going into production should have that final seal of confidence and compliance approval. So once we move from build to deploy, the next stage is obviously we're going into production and we want to monitor our runtime assets. Here at Uptycs, one of the most powerful tools we use at Uptycs is Yara to help you identify and classify malware at scale. For example, when Log4Shell hit, we were able to put together a Yara query that checked Log4j configurations and if exploit attempts had occurred on the host. And we were able to configure this so it could push out to over 1 million hosts in under 20 minutes, showing right away the scale and lightweight nature of the tool, but also how useful it is for dealing with emerging threats that require you to pivot on a dime. When protecting your production assets, it can be stressful, and periodic scans are often not enough. You need that 24/7 real-time visibility because you don't want to miss a potential gap, and you want to ensure that when you protect your assets, they're being monitored to the level they deserve and truly need. And finally, we talked a bit about that lack of support for Linux and just some interesting aspects around Linux security tied with containers. eBPF, though, is a really interesting Linux kernel technology starting to get adopted. It allows you to work safely and directly with the Linux kernel, which greatly reduces the resource utilization needed when monitoring extremely high volume of event data. I don't want to stick on these slides too long, though. So Saurabh, I'm going to hand it over to you for the platform demo, and maybe you can kind of show us some of these hands-on solutions at each of the build, deploy, and runtime solutions.
Thanks, Jeremy, for this great introduction. And before I dive into demo, I have a couple of more slides. I promise just two. And I'll be covering like the security concerns when it comes to container security and how Uptycs can address those concerns. Jeremy, if you could just move to the next slide. The next one. Yeah. So these are the concerns while securing containers. The first one is securing the host OS. The second is container network traffic. So typically when containers are in production, they are immutable. So any communication going from within, like, going from inside the containers to the outside world can be malicious. Maybe it's talking to a command and control IP. Then the security of the application inside the container. So since containers typically leverage a lot of third-party components, they need to be evaluated for any vulnerabilities or weaknesses. Then malicious behavior within the containerized application. So take, for example, you have a baseline of all the processes that are seen within a container, but if there is a malicious process which was never seen before, then you can detect something malicious is going on. The containers that are not properly isolated from the host. So there's the classic example of a container escape where a malware, for example, or malicious actor can gain access to the underlying host or even the Kubernetes cluster if he gets access to a pod, right? And then failed compliance audits. So what we have is like, if there are like CIS security recommendations that define, the recommendations for a Kubernetes cluster, you can see how many, like, if they are sticking to those baselines or not. We'll show you how Uptycs can help you achieve these concerns. I'm going to address these concerns, sorry. Can you move to the next slide, Jeremy?
Perfect, yep, here you go.
So there are two different ways how we can get telemetry from a cluster as well as from inside the containers. So we have a product called KubeQuery, which gives us the control plane information. And using this information, you can actually run CIS benchmark checks, whether it's for on-prem Kubernetes or Kubernetes in the cloud, for example, EKS in case of AWS or GKE or Azure. And then the second piece is Uptycs OS query. So we have our own a containerized version of OS query that we deploy on the nodes, and we get that in-depth telemetry from inside the containers that, what processes are running, what socket events are there within the container, if there are any communications that are open, and so on. So I'll start sharing my screen right now.
Perfect. I'm gonna go ahead and stop sharing.
Yep.
And thanks for setting the stage. Also, I think that's really helpful to kind of walk back through a bit of those concerns around container security, and then showing kind of what our kubequery backend looks like before we get to dive into it. So thanks for doing that.
Thanks, Jeremy. So first is, imagine you have your developers team building images. What we can do is we can integrate within your CI/CD pipeline. So if you're using tools like Jenkins, we can integrate with those tools, and we can run vulnerability analysis during build time, deploy time, or runtime stage. So during build time, if there are any vulnerabilities that need to be fixed right away, you don't want to deploy an image which goes into production, and then you find out that, hey, there are so many vulnerabilities. Score is, because that's really important in case there are vulnerabilities with CVSS score of 10, for example, then you know that these need to be fixed right away. And again, as Jeremy mentioned, that deploy time scanning is also of utmost importance. So we also run a vulnerability scan during deploy time, and we let you if there are any vulnerabilities that might have creeped from build time to deploy time. And if everything looks good, your containers goes into production, then with a period of time, new vulnerabilities creep in, right? And new vulnerabilities creep in. You run a scan, and then again during runtime, we let you know what vulnerabilities are there within containers, what's the criticality, what's the CVSS score, again to help you make those informed decisions that, hey, I need to patch these vulnerabilities right away. And then, like, if your vulnerabilities are fixed, you have your own, your Kubernetes cluster is set up, then you also have the capability of running CIS checks, right? As I mentioned before, that CIS benchmarks security recommendations, the best practices, I would say, for Kubernetes. And we have, you can run those for on-prem Kubernetes, or if you're running EKS or GKE or Azure, we have the capability of running the CIS checks for those as well. Hence, you can get that visibility of how much deviation is there within your cluster from those security recommendations. Now, coming to intrusion detection within a container, right? So take, for example, a container that's running in production, a vulnerability, cropped up, it was not patched, and an attacker got access to the container, right? And what he did was, he was able to SSH into the container, and he launched a malware. So we have this detection engine inside Uptycs that we can use to detect those attacks, right, or intrusion. So what happens is we have these event rules, and when we are looking inside the containers, we are typically looking for behavior patterns. Right? If I filter down these rules according to the containers, you see that we have close to 105 rules specifically for containers. And if I open up one, you will see what we do to detect any malicious processes running within a container. So in this case, we are looking for the AT utility, and we are looking for conditions that, it's a container process, yes. And if the path ends with bin/AT, or the exe name is equal to AT. So we are looking for these conditions. And what happens is, if a container gets compromised, right? An attacker launches an attack within a container or using it for crypto mining, for example, a series of these signals or rules will get fired, right? And it's on the same container. What we do is we combine those together since they are correlated, and we take a 15-minute interval and we form a detection. So detection is more high fidelity, right? I'll show you what I mean. If I go to this particular screen, right? So I just navigated to this containers, detections, and I chose one of the high score detections, 10 on 10. You can see the threat score. In this case, we see there are 24 signals, right? And on the right-hand side, you see the list of those signals. Right? For example, process dropped executable file in /etc directory. If you want to see where this is on the attack matrix on the left-hand side, simply click on this and you will see that piece highlighted. So it's under tactic execution, and the technique is T1204 user execution. And if you want to get more information, for a particular signal, you can simply click on it, and it will give you, for example, what's the process, what's the PID, and what are the parent processes. That's really important to understand, because if there are a lot of processes giving birth to child processes, we need to understand that we need to have that ancestry to see how the attack spawned within the container. So this is a list view, but if you want to see any graphical view, right, if you want to visualize this on the UI, that how an attack spawned within the network, what exactly happened, if there were any socket communications that were open to an external IP, and actually we can detect malicious communication with the command and control IP using our threat intel. In this case, we see that a communication was opened over port 443 to this particular IP address, and if this IP is malicious, we'll tell you that. So I covered the proactive approach in case of container security as well as reactive. So you have, you like the build time scan, deploy time scan, runtime scan, scanning for all those vulnerabilities and fixing them beforehand. And then you have the capability to run those CIS benchmark checks, which are security recommendations for Kubernetes. And then if there is an attack and there is a malicious process within a container, you can detect that. And you also have this way where you can actually form a baseline of the processes inside a container. So take 30 days worth of data, form a baseline, and if you see a new process on the 31st day, for example, you know that it can be malicious. So this is how Uptycs can address the security for containers and Kubernetes, and it's both on-prem as well as in the cloud. So if you have any questions, please feel free to ask, and we would be more than happy to answer them.
Awesome. Thank you so much, Saurabh, for kind of walking us through that. One question I have is if we could go back to either the build or deploy or runtime stages. I'd be curious if we can dive a little deeper into some of the context that Uptycs give you when we look at a vulnerability or a finding. So I know we kind of don't just hand you the vulnerability and say, go look at it yourself. We kind of give you some context around that, kind of finding the CVS score, what image build, and some insights around there.
That's correct, Jeremy. So as I showed before that, we have vulnerabilities which we show as well as which we ignore, which are not, not critical. But yes, if we have the CVSS score, and for example, if we have vulnerabilities with CVSS score of 9 or 10, we know that developers need to fix them right away before moving ahead in the development cycle.
Yep, perfect. Is there anything else that you wanted to show while in the platform? Or I'm happy to share my screen again and we can open it up to some Q&A.
Yes, your ground is all yours, Jeremy.
Perfect. All right, let me know when you can see my screen.
Yep.
Perfect. Well, if anyone has any questions, please feel free to ask them. We'll keep an eye on. I saw a couple trickle in, so I'll go ahead and take those. One of them was pretty simple. Sorry, if you want to take it. Do you support AWS Fargate?
Actually, we do. Yes, we do. We support AWS Fargate as well.
Awesome. And then another one, maybe from the same person. What if we have our own custom Kubernetes version? Do you support that?
We definitely support, if you have your own, custom Kubernetes version, it's as simple as deploying a containerized OS query on the nodes, and it will give you that in-depth telemetry of, what's going inside the containers.
Awesome. That's great. I'm seeing a question around, okay, you mentioned don't just shift left, make sure that we're shifting left in the right ways. Do you have any thoughts on shifting right beyond the CI/CD pipeline? Yes. Earlier on in the presentation, we talked about, when you shift left in your security practices, also think of kind of the observability around your CI/CD pipeline and getting that granularity into, okay, how your container is actually being built and spun up. When we shift right of that CI/CD pipeline, we're looking kind of beyond that runtime solution and kind of into what being quoted as the mesh of your IT ecosystem. And I think the conversation here would be more of like a CIEM KIM solution space, kind of that CNAPP CWPP solution as well. So I think there's a little more, quite a few webinars we could do on shifting right of the CI/CD pipeline, but it's a great question. And I think one of the more interesting pieces of that would be that kind of user analysis KIM solution space. Let's see if anyone else has any other questions, feel free to add them. So one of the questions that we tend to get also is kind of tangible action items, say at each stage of the CI/CD pipeline. And, maybe specifically the build stage is a big one for people trying to reduce that snowball effect. I'm not sure if you have any thoughts. I know I always tend to say, focus on those vulnerabilities that come in and really make sure that you're mitigating and patching any vulnerabilities that come in for your software or hardware assets. But did you have any thoughts on kind of a tangible action item at the build stage, maybe?
I agree with you, Jeremy. So, when, as I said, we integrate with the development cycle, the CI/CD pipeline, and vulnerability detection is a great start, because that's when you catch, something which might prove, problematic down the line. And we don't want to lead it to a snowball effect, right? We want to catch it beforehand and fix it right away. So if more critical the vulnerability, the better it is to fix it right away.
Perfect. Thank you so much. Well, we've reached the end of our time here. If you have any other questions, definitely reach out to the email here. Feel free to email myself or Saurabh. We're both happy to talk about anything on containers or just security in general. We love chatting about the stuff. And if you have anything specific that wasn't answered during this conversation just now, like I said, feel free to drop us a line on the email or just informally or formally, either way, and hopefully we stay in touch. But yeah, thank you everyone for joining the call today. Hopefully you learned a bit more about the container space and some CI/CD solutions. But yeah, thank you so much. Have a good one.